Good afternoon. Welcome back. I don't know in which room have you been, so now you're in hall one with me. Uh, Very interesting previous presentation on Terraform, and now we will go to running Oracle on Kubernetes. My name is Yelena Sobolevska. I'm coming from Riga, from Accenture Baltics, and you can find me on LinkedIn if you have any questions or collaboration ideas. And now I'm presenting to you our amazing conference participants, Ron Ekins. Good afternoon, Ron. How do you feel today?
Good afternoon. Very well, thank you. Thank you for having us. Looking forward to today's session.
I've read the description about you, and it says 30 years of experience. So you've seen the no internet world, big computers that do very strange things, in my opinion.
Mhm.
What was the biggest wow effect for you in these 30 years of development of IT world?
Okay, it's an interesting question. I guess when I joined IT, it was very much you worked independently, and the I saw like the first sort of Windows work group, sort of local area networks being put together, and Windows NT. So the collaboration and the sharing of ideas and documents and development activities on a network rather than working standalone PCs. So yeah, I guess computer networking is the big change, and then taking that forward and then collaborating externally with the internet. So seeing the birth of the internet and the way we now collaborate, and also developing the cloud. So yeah, it's gone from working individually on a desktop to in a team, to company, then global.
And like now, you're sitting now in somewhere near London, and I'm here in Riga. People are mostly probably in Lithuania, but all over the world. And that is amazing how knowledge are shared nowadays and how effective it is. And young people don't really understand that it's a miracle because we've seen it before internet, yeah, like how we lived, and now it's just like a different world. And thank you, Ron, for making it better by sharing your knowledge and expertise with community. It's a big input for our lives. So, running Oracle on Kubernetes. Ron, the stage is yours. Thank
Okay,
you.
thank you. So that's myself on the right hand side, Ron Ekins. I work for Pure Storage, where I'm a principal field solution architect. Uh, I have an active Twitter account at Ron Ekins. Follow me there. So whenever I do a presentation, a conference, or write material for my blog at ronekins.com, I also put code example at my GitHub repository. So if you see anything interesting in this presentation, follow me, visit my blog, and look at some of the code examples. So, agenda for today: an introduction to Docker and Kubernetes. They are related, and we'll talk a bit about that. And then I'll talk about the Oracle journey with containers, uh, the need for persistent storage, and give you some takeaways about how you can build a containerized Oracle database and where we're going in the Oracle world with our database Kubernetes operator. So, Oracle and Kubernetes. So, the man on the right there is a conductor. And really, that's what we should think of Kubernetes being, the conductor of our computing resources. Its main job is to manage the desired state. But what does that mean? Workload placement, keeping things up, keeping things running, managing the state. Load balancers as a service across multiple worker nodes, managing the network infrastructure for us, and persistent storage. And when we talk about databases, we focus on the persistent storage. Declarative mode, we tell it what we want, and we let Kubernetes do it for us. So Docker versus Kubernetes. And I guess there's been confusion historically with Docker Swarm and thinking that they are the same, but no, they're related. They're different technologies, but they are very much complementary. So they aren't direct rivals, but they are related. So Docker is the container platform, like Podman. Kubernetes is an orchestration platform for things like Docker, but not just Docker. So there we have it. So quick, there are lots of sessions on Kubernetes, so I wasn't going to spend too much talking about Kubernetes because I could spill the whole 40 minutes on that. So let me talk about what Oracle's been doing in the container world. So surprisingly, it's been very active for quite a long time. The first version that Oracle shipped was 12.2. This was in Docker Hub, and this is probably over 6 years ago now. But it hasn't been really maintained for over 5 years. So that is a legacy version. Actually, Oracle 12.2 is out of support, so it's there here for historic reasons, but not really actively maintained or something really you should be looking at. If you do want to have a look at running your Oracle databases in Docker or Kubernetes, visit the Oracle Container Registry at container-registry.oracle.com. From there, you can see the containers that are available. So Oracle 19C is the current long-term support version. So you can get a Docker image there, a pre-built Docker image, and you can download that and use that. You have to agree to the licensing terms, but if you have an Oracle contract and you are licensed for it, you can download that. There's also an image for 21C, what's an innovation release. So 19C has our long-term support release, and that's where most Oracle customers are living on. But if you want to take a newer version, there is 21C available. But for many people on this call who want to learn a bit about Oracle, I would say have a look at the 23C free version. So Oracle's taken the unusual step is actually releasing a version for developers before it goes GA. So Oracle 23C hopefully will be released sometime this year. But in advance of that, developers can see all the features of Oracle 23C with the free developer release. So that came out last month. There is a number of ways you can get hold of this. But, here is a Docker image. So we can download that with Podman or Docker, and we can use that. And you don't need any Oracle contract. You don't need a single sign-on. You don't need any licensing agreements. You can use this. It's free forever. So on my Mac, I pulled the image, and you can see the Podman image there. And I can then run that image through Podman. And that starts my database up. See the Podman PS, so it's like a Docker PS. You can see the process running, and there's my database is up. And I can connect to the database, and now I have a Oracle database 23.2000 running on my Mac, just with one line of code using Podman run. So that's really powerful, really efficient way of learning a bit about Oracle. And if you haven't got a cloud account, you can do this on your local machine and get up and running really fast. The Oracle repository also has some other stuff there. So Enterprise Edition, the Client, Standard Edition, and Rack, and you can take those. But it has got only a limited number of Oracle versions. However, what Oracle has provided is build scripts in a GitHub repository. If you navigate to their GitHub repository, go down into the Oracle databases, you can see scripts for the 23C, 21C Enterprise Edition Standard Edition 2, 19C Enterprise Edition Standard Edition 2, and Oracle 18C Express Edition. So Express Edition is the same as free. It's a developer edition, so there's no licensing requirements for that. So if you want to learn a bit about Oracle, you have a choice now. You can go 18C or 23C. And for legacy support, 18C Enterprise Edition, Standard Edition 2, 12C Release 1, Release 2, and Oracle 11G Express Edition. So we've got lots of options there. So we can build our own Docker image to be used Docker, Podman, or in Kubernetes. What about support and licensing? Yes, we're covered there as well. So Oracle support databases running in Docker, and they have done right back since 12.1. So it's not something new. So it's a well-established position to be in. But what has changed recently is the support for RAC databases. These are clustered databases, real application clustered Oracle databases. We can see there that 21.3 and 19.16 are now supported for production use. So if you want to run Oracle RAC in production, you can do that with Docker now. Previously at 19.3 and below, it was only for development and test. Okay, what about licensing? So when you run an Oracle database, you have to license the compute. So it becomes a little bit harder in a Kubernetes world because you don't necessarily know where it's going to end up on which worker node. So the license agreement is very similar to a virtual machine for VMware, where you have to license the platform. Oracle's got a really good paper there about running and licensing containers, and basically you're licensing the physical machine, and then you use Kubernetes topology rules to make sure that you know where it's running, because it doesn't agree to the partitioning policy. So Oracle recognizes some partitioning to be hard partition and some soft. So you have to be very careful that you actually understand what machines you're licensing and where your Oracle database is going to be running. If you're using the 23C edition, you don't need to worry. So the need for persistent storage. So containers versus databases. When we think of containers, we normally think stateless. We think that they're disposable. They can be thrown away and rebuilt any time. We don't have to worry about the storage so much. Typically, lifetime is short, maybe minutes, hours, or days. We treat them like plants. If one dies, we get another one. We don't have to worry too much about it. Location independent, don't usually use local storage, floating IP addresses, host names, tend to be lightweight, very dynamic, but small, megabytes or even gigabytes of memory, but not large footprints. And likewise for the storage, minimal I/O and minimal size, maybe some networking I/O. But that's not what we think of when we think of a database. By design, a database needs to be stateful. We need to persist our information. That's the purpose of a database. So our life cycles are typically longer. We don't normally spin up a database for minutes because it takes a long time to populate the data, and we look after the data. So databases could be hours, days, or even years. So very different life cycle. We treat them like a member of the family. We look after them. We protect them at all the costs. We think about disaster recovery. We think about high availability. We make sure that we have backups. We want to make the data is important. So we have the container, which could be an image, which we can generate at any time, but our data inside the database needs to be protected and persisted. Often the databases have information about the database location. We have connection strings from our applications. So we need to know where the database is. Could use local or shared storage, could be an IP address, could be a fixed name, but they're heavyweight. They use large amounts of memory, lots of storage I/O, and some network I/O as well. So there's some similarities, but some big differences. So we need to think of databases slightly different when we containerize them. Database needs persistent storage. And this is where the CSI comes in. So the Kubernetes CSI standard supports storage features, so which we see on traditional storage platforms. We can do dynamic volume provisioning, so we can allow volumes to be created on demand. So this could be on premises or in the cloud. Like volume snapshots, so snapshots of a volume to give us a point in time recovery. Volume cloning, so we don't have to copy data from one place to another. We can do this at the storage level. So cloning for storage volume, which is really important. So if you have a multi-terabyte database, you don't necessarily want to rebuild that database time and time again for development and test. You can clone that and reuse that. Access and volume modes. So CSI supports read write once. And this is what we typically see. However, there are cases where you need read write many or read only many. So read only many could be good for log files audit files where you want those in one place, but many people can access them to read them. When we have sophisticated solutions like RAC, we need read, write, many. So in a RAC environment, 2 database servers will be using the shared storage platform, both writing to it at the same time. So the volume can be mounted as read, write by many hosts, and this is all possible through the CSI driver and the storage platform. CSI supports both block and file and those volume modes. So we're covered from Kubernetes point of view. So dynamic provisioning. So here we have a pod, storage class, and physical storage, be that NFS or block. We create some volume mounts and our pod definition. So here I have 3 of my data, some scripts, setup and startup. So every time my container starts up, it runs a startup scripts, but the initial one-off on the setup, it can run scripts in there. So I created 3 volumes. I then defined some PVCs and some claim names. Distant volumes claim has the size, a selector, and a storage class, so it knows where to go. The storage class points to a storage class, which then points to physical storage, that could be NFS or block. The request goes to the storage platform that provisions the storage and makes that available. So let's see how we can build a containerized Oracle database. So I like to break this down to a few steps. So first, let's create a dedicated Kubernetes namespace. Then a secret to connect to the Oracle registry, and then a configuration map to hold our database variables. So we're not going to go into the container. We can do this all remotely from the kube control. And then our Oracle 19c database, which is, I say, is the long-term support maintenance database. So here we have a namespace. I'll just call this one Oracle namespace. So I can kube control apply that file, and that will create me a namespace. Using my Oracle single sign-on credentials, I create a secret. Here it's using the Docker username, Docker password syntax, and I'm putting that in, and I'll specify those. But the server isn't Docker Hub, it's containerregistry.oracle.com, and this is going to create me a secret. My configuration map, I like to maintain a file. I've called this oracle.properties, but my configuration map supports multiple versions of Oracle, 12c, 18x, and 19c. And you can see some of the variables have changed over time. Oracle 12 with db underscore sid. From 18c onwards, that got changed to Oracle underscore sid. So db became Oracle. db pbd, Oracle pdb. And then there's some new features added at release. Oracle 19c gave the ability to change some of the Oracle init or parameters. For example, init underscore sg size, so our SGA size. Init underscore PG size, our PGA size that we would normally set an Oracle database. So I create my configuration map from this properties file, and that's going to be something called OraDB. Now to create our database, I want to set up some storage. So I have a storage class. The storage class has got a replication factor, and I've said it's an IO profile using the Portworx storage class here with a high IO priority. Allow expansion equals true. So I want to be able to grow my volumes dynamically. So I've set this to true. My volume claim, startup, setup, and our data. Read, write once, a size, so how much storage I'm requesting from this storage class. So I say where it's going to be, give it a name, and what access mode. So access mode, read, write once, 10 gig, 1 gig, 20 gig. So I have different sizes for each of the volumes. Kube control apply minus the file name, and that's going to create me a storage class. So running Oracle on Kubernetes, we need to think about startup and shutdown, and we can do this. We can use Kubernetes to do this for us. So kube control scale, my namespace of where my deployment is. This is an 18c one, so I change the replicas equal to 0, shut it down, and back up to 1 to start it up. All from kube control. So I haven't had to visit Oracle or know anything about Oracle to stop and start my database. Same for Oracle 19c. So we could also use a deployment or a stateful set. So it's the same image, we just got different ways of controlling that. To delete the database, to remove it, delete stateful set, and then the name of the namespace, -n namespace. Or deployment the same. So delete deployment / deployment name, Oracle 18c in this example, and the namespace. We can move and relocate our database. So use Kubernetes to manage the location. So the database is up. I've cordoned the node that it's on currently. I can shut the database down, and then Kubernetes will detect that it's gone down and start it up. So if I kill my database, cordon means it won't reschedule on that same node. It'll find another one and it's moved it. Once it's done this, I can then uncordon the node to make that back generally available for scheduling. Wherever possible, we need to avoid hard coding. So use kube control, get, and JSON, and pass that output into environmental variables so that we can have very repeatable scripts. So we can have whether that be an operating system bash script or just our commands that we maybe have an alias set up. We don't want to be typing things again and have to think about it. So getting our Oracle database listener, from the service, kube control get service. So 1521 is the database listener, and that's the external port. So kube control get service, and here you can say I've used the JSON path with the specifications looking for port 1521, and it returns me the node port. So now I can capture that and save that as a variable. Get the database SID, Oracle name from the configuration file. So Oracle SID, pass that back out, and I've got my database name. So we can build up all of these variables, and we can use those in our existing scripts. So that was a lot of effort there, really. So I've got a YAML file that I can apply to my database. Once that's available, and we can change the variables, so it's quite dynamic, but it's not the easiest way to deploy a database. The simplest way is with Helm. So Helm is very similar. If you're in a Linux environment, you're used to Yum or maybe RPMs. You can install packages, and we can store a database in the same way. So the database can be deployed through Helm. So we install Helm with Helm install. So this gets us the database in, and we can take the charts which have already been published by Oracle on the GitHub repository, and they do support customization and extensions. So how do we do this? So git clone the Docker images back, and then Helm package Docker images, the Oracle database single instance, the Oracle DB chart. This then creates that for us. We can then do a Helm dry run install to make sure the configuration is right by doing --dry run. I've got a values file there. I've got -f values.yaml, and that's where I can do the customization. And this will then allow me to change the Oracle SID, the Oracle password, and other variables that are in that file. So we have that customization, but with a few lines of code, we can pull an image back and we can build a new database. If you want to read more about that, it's on my blog and ekins.com, and you can find out all about that or follow the link there. This is where I want to introduce the database operator. So we've been able to deploy Oracle databases for a while now, really efficiently. Makes it very easy. But we've had to pull images back. We've had to worry about maintaining YAML files and configuration, secrets, thinking about storage classes. The database operator pulls all this together. So the operator is a way of packaging, deploying, and managing a Kubernetes environment. It helps us to deploy cloud native applications, automating a lot of the deployment, scaling, backup locations. And different operators have different functions, different features. So not all operators are the same. There are many database operators. So if you go to Operator Hub.io, you will see most databases have multiple operators. So multiple operators for Kubernetes MySQL, Kubernetes and Postgres. And you can decide which one of those has the features that you require. They may have different backup solutions. So you can pick the right one for you. But the Kubernetes operator provides a consistent way of deploying a database or application against on-premise and different cloud vendors. The Oracle Database Operator has taken this concept a bit further. So kube control is the language of choice for Kubernetes SREs and for anyone that's working in the Kubernetes space. But it's not something that Oracle DBAs typically use or Oracle database developers use. Kube control is not just able to manage Kubernetes databases. It can actually be used as a command interface to manage traditional containerized databases. And what Oracle means containerized database, a pluggable and a container database. So that's the disk drive that looks like a USB drive, and then the containerized Docker style database with the whale. So we can use kube control to manage containerized Oracle databases and also on-premises databases and Oracle Cloud autonomous databases. So this is one interface to manage all databases. So as a developer, as an SRE, if you know the kube control Oracle database operator, you can manage all databases. You don't need to be using SQL Plus or other database commands. It's work in progress. The Aura operator is version 0.2. So that came out recently. So 0.21. Version 0.1 was available last year. And the features have increased. So it's autonomous database in Oracle Cloud, OCI, dedicated databases on premises, so single instance, or OKE, which is the Oracle Kubernetes Engine databases. So anywhere the operator is deployed, you can manage a database. So sharded database, rack databases, all can be managed through the operator. From a support point of view, it said the operator should be multi-cloud, multi-environment, and you can use it with OKE, the OLCNE distribution, Minikube on your laptop if you're using that, but also Azure, AWS Container Services, and Red Hat, OpenShift. So there's multiple places we can use the Aura operator. Note, do not use in production. This is development and test. It's 0.21. It's not GA, so this is an active project. If we want to run on Oracle databases in Kubernetes at the moment, follow the steps I talked about using either Helm or a YAML file. So we have the OKE operator now, and one thing that's just come out in the last month is OKE now supports enhanced Oracle Container Engine clusters, and this allows us to install add-ons when we build our OKE cluster. So the Aura operator has some prerequisites. It needs a cert manager, and also you need the database operator. And these can be built into our container engine. We can script these through Terraform or through the command line interface or through the web UI. So we can get this Kubernetes OKE cluster built, but now we can build it at initialization time to have the database operator installed. So I built a cluster in my Terraform script, and you can see that I've installed Certification Manager and the database operator. They're on the bottom right corners and they're green. I haven't selected the Kubernetes dashboard, so I don't need that for what I'm doing. So we can have this go into our OK. We don't need to install the operator as a post step now. And that's what I wanted to share with you today, was how you can use OKE or operator to deliver Oracle databases. I would normally do a live demo, but using remote access, I didn't want to rely on that. So I wanted to give plenty of time for questions. So is there any questions?
Thank you, Ron, for a very interesting presentation. So, do we have any questions? There is a delay And I can see that participants still see your presentation, so should be any moment when it finishes. Okay, this is not relevant. Q&A section. As your presentation was very well explained, there might be a situation that there are no questions. It was like, yeah, okay, we got it. Q&A. No questions today. Thank you very much, Ron. It was brilliant, and I've really enjoyed listening to your beautiful English language. In IT world, you meet a lot of people, and English sounds very different. So it was a pure pleasure.
Much. So I guess that as a leaving comment, I'd say that if you want to try this, visit the Oracle site, container registry, pull back the Docker image, and have that running on your laptop, your PC, or your MacBook if you're using that. So you can do that with Podman, so you can experience the Oracle 23C release. If you want to use Kubernetes with Oracle, take yourself an Oracle free account. You can go to OCI and you can create an Oracle free account and get $500 worth of credit. So you can experience the Oracle Cloud. You can create some virtual machines which are free forever. So you can create your own development platform and get yourself going, which is really good. As a developer, we want to use free stuff. So visit that and take advantage of those offers. Have a play with OKE or other distributions. If you need to understand and get up and running with Kubernetes, the best place to start that is on your own machine. So install Minikube and fire up your own cluster. Then you can visit my site and you can find the YAML files and the manifest to build an Oracle 19 database. If you want to do it in the cloud for OCI, I've got Terraform scripts which will walk you through that complete build and installation. So play with Helm, play with Minikube, play with VirtualBox, use all the free tools out there and all the facilities we have open to us. So it's not just OCI. You can go to Azure, you can go to Google. They all have some free credit available. So use the free credit, create your virtual machines, and become more familiar and experienced with Kubernetes. Even if you're not using it today, you may be in 6 months' time, maybe a year's time, 18 months' time. So it's always a good learning opportunity.
Thank you very much, Ron. You're like encyclopedia for us, with all the advices for resources, how to do it, when to do it, where to do it. And you're right, Kubernetes is very hot, and all the projects, not all, but many projects want Kubernetes skills. So very valuable to learn it if someone still haven't. Thank you for your time. So last time checking, still no questions. Everyone went to make their hands dirty.
Yeah, or maybe everyone's going to lunch
as well. Yes, enjoy your lunch. Thank you for your time. It was a pleasure to meet you.
Yeah, thank you very much, and look forward to meeting you in person one day. Bye-bye.
This is all we got. Remember the revolution in our minds. This is all we got. Lock me out of this life institution. I am angry and high on illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a human. Oh.